We've been learning how to distill arguments. That is, to identify arguments and extract the main thrust of one from a body of text. As we move forward and work towards completing more complex examples of this, it's going to be helpful that we distinguish between different types of arguments. And you may have already gotten some sense for different argument types that exist just based on several of the examples I've been using. For instance, here's an argument that you may have seen something like this so far. All men are mortal, Socrates is a man, therefore Socrates is mortal. And think about this argument and compare it with this one that appears on the right. Jones's DNA is on the murder weapon. Jones has the motive to kill Sam, therefore Jones is the killer. And think about the difference between these two arguments. There may be a couple of distinctions that jump out at you, or differences that jump out at you right off the bat. On the one hand, you look at the argument on the left, there are two terms that appear in the conclusion, Socrates and mortal. And you notice that both of these terms appear in identical form somewhere in the premises. Here in the second premise we see Socrates, the word mortal, well, that appears right here in the very first one. But look at the argument on the right. We do have one of the terms, or a synonym of it, he right here, which is of course referring to Jones. But then notice the word killer appears, and killer doesn't appear anywhere in the premises. We do have the verb kill, we do have the verb murder, but killer, a noun here, is a different concept that's being presented. So one thing we can say, or one difference we notice between these arguments, is that the one on the left, the conclusion, the concepts in the conclusion are completely contained within the premises, whereas the argument on the right, the conclusion presents a new concept that's not completely contained within the premises. There's another important difference we notice as well. If we look at the argument on the left, it seems that given that the premises are true, the conclusion has to be true with 100% certainty. That is, if you assume, let's pretend we don't know if it actually is, but just assume that 1 is true, assume that 2 is true, it seems that 3 absolutely, undeniably has to be true. Whereas the argument on the right, even if 1 is true and 2 is true, at most this conclusion is only likely to be true. And this right here represents an important distinction between these two arguments that exist. And we have names to describe these two classes of arguments. And we're going to divide these into the following classes. On the one hand, we have what we call deductive arguments, and on the other we have inductive arguments. And a deductive argument is one in which the arguer intends that if the premises are true, then the conclusion must also be true. Whereas an inductive argument is one in which the arguer only intends that the conclusion is probably true if the premises are. And these represent two broad classes of arguments. Deductive arguments you should really think of, and inductive arguments you should think of as representing families of arguments. Within the heading of deductive arguments, there are scores and scores of different kinds. Within inductive arguments, there are scores and scores of different kinds of arguments as well. But noting this distinction between the two, that the one hand you have an argument in which the premises are supposed to guarantee the conclusion, and on the other you have an argument in which the premises are supposed to render the conclusion likely, is a very important distinction for enabling us to further analyze arguments. It's also important not only for the purpose of analyzing an argument and trying to figure out what the arguer is trying to say, but it's going to turn out to be very important for argumentative evaluation as well. These two different arguments play by different sets of rules. They're trying to accomplish different things. And for that reason, we have to judge whether or not an argument is good or bad based on what it's trying to do. We don't judge an argument, say an inductive argument, by deductive standards, because that wouldn't be exactly fair. You judge the argument according to what it's trying to accomplish. To give a quick parallel, I mean, think about a song, whether or not a song is a good song. Well, that depends on the type of song it is. If, for instance, the song is a love ballad, well, then you judge it according to what makes for a good love ballad, which, I don't know, a good love ballad fills you with feelings of romance, or maybe feelings of nostalgia. You're missing that lost loved one. You know, I don't know, you're crying like, I remember when she was mine. You know, it's that sort of thing. If the song does that, then it's a good love ballad. What makes for a good heavy metal song? Completely different, right? A good heavy metal song, it makes you, I don't know, want to tear stuff up or punch your mother in the face or whatever a heavy metal song does. But it wouldn't be fair if someone performed a heavy metal song and was like, yeah, I just wanted to, drive my face through a brick wall, but it didn't fill me with feelings of romance and love. That wouldn't be a fair criticism at all, because that's not what it was trying to accomplish. And we use the same kind of assessment when we are thinking about arguments, or we apply a similar way of assessing things. When we judge a deductive argument, we judge it according to deductive standards. When we judge an inductive argument, we judge it according to inductive standards. Now this right here just represents visually exactly what I was saying, but it brings to your attention a very important point to make about the difference between deductive and inductive arguments. The difference really comes down to what the relationship is between the premises and the conclusion. Now you look at the argument right here on the right. Notice in the deductive argument, basically what this is representing here is to say, given that the premises are true, they're supposed to guarantee with 100% certainty the conclusion. Whereas the argument on the left, what this is demonstrating is that given that the premises are true, it's supposed to render the conclusion likely or probable. And so I'm representing here, like I said, visually what I've just said. You have to note that the difference between the arguments is really a function of how the premises relate to the conclusion. The difference is not about whether or not the premises are true. The difference is not about whether or not the conclusion is true. The difference is about the structure of the argument, how the premises are supposed to be related to the conclusion. And keep in mind also, the relation between the premises and conclusion is a function of the intention of the person making the argument. What does that person reasonably intend to do with the premises? Are they using the premises as a guarantee of the conclusion, or are they using the premises as, I don't know what a quick noun is, but just a way of making the conclusion likely? I want to give you some examples of deductive arguments because I think this will make matters a little clearer. So here's an example of a deductive argument. John is a bachelor, therefore John is unmarried. Now, if the premise here, John is a bachelor, is true, is there any way for the conclusion to be false? And the answer is no. The conclusion is 100% guaranteed. Why is that? Well, because a bachelor, by definition, is an unmarried male. So the conclusion necessarily follows from the premise. Here's another example. If Jesse is a man, then he is mortal. Jesse is a man, therefore Jesse is mortal. Again, look at the premises. Number one, if Jesse is a man, he's mortal. Premise two, Jesse is a man. Now, assume that those are true. We don't know if they are. We don't know if they're true or false. Doesn't matter, but assume they are. Does the conclusion have to follow with necessity? And the answer is yes. Notice here is going back to something I said earlier. The conclusion in both of these is contained within the premise or the premises in some way or another. Here's another example. All fish have gills. Nemo is a fish, therefore Nemo has gills. Yet again, we have that concept containment appear. We notice we have our subject term right here in the conclusion, Nemo. That appears in one of the premises. We have gills right here is the predicate term in the conclusion. When that appears right here in one of the premises. And like I said also, if the premises are true, the conclusion must be true. And notice that these are three different types of deductive arguments. The first one I'm calling definitional or conceptual. It's a one premise argument, and basically the conclusion is just a reiteration of the definition of the key terms in the premise. The second one is a hypothetical kind of deductive argument. If then, if A then B, A therefore B. It's just a hypothetical if then kind of argument. The last one is what we're going to actually study, the last one in some detail. I'm calling it right now class containment. We're actually going to call it later on, I'll just throw this out there, it's called a categorical syllogism. Don't worry about what that means right now too much. But notice the last argument up here is talking about not hypotheticals, but it's talking about relationship between various classes of things. And right here, it's talking about fish, the class of fish. And it's saying all members of the class of fish has gills. Nemo belongs to this class of things. Therefore, Nemo has gills. So all three of these are different types of deductive arguments. Now compare this with some inductive arguments. John had the motive to kill Sam, and John's DNA was found on the murder weapon. Therefore, John killed Sam. Even if the two premises are true, John had the motive to kill Sam, and premise 2, John's DNA is on the murder weapon, that's no guarantee that he killed Sam. There's no guarantee whatsoever. That seems to be, the conclusion seems to be going beyond just the information contained within the premises. Sally is a Democrat, therefore she's pro-choice. Here again, the conclusion is not a guarantee. It's likely, just given Gallup polls and trends within political parties, but it's not necessarily true. Finally, the federal government needs to cut spending. It doesn't make sense for you to spend more than you make. Likewise, it is irresponsible for the government to do so. This is another type of inductive argument. In this one, the conclusion is not guaranteed in any way from the premises, and the conclusion seems to extend beyond just what is said in the premises. And here again we have three different types of arguments. The first one is called an inference to best explanation. In the first argument up here, basically what is going on is the arguer is laying out a few data points. It's like, all right, data point number 1, Jones had the motive. Data point number 2, John had the motive. Data point number 2, John's DNA is on the murder weapon. The likely explanation for this, or the best explanation, is that he killed Sam. Now, there are other possible explanations. Maybe John was framed. Maybe, I don't know, aliens, made it look like John did it or something. I don't know. I mean, I know that's far-fetched, but there are other possible explanations as to what is going on here. Maybe John had the motive. Maybe everybody had the motive. Maybe John's DNA was on the murder weapon because the murder weapon was stolen from John's house and just happened to be used in a heist. I'm trying to give the range of possible explanations here. But you look at a set of data points. This is what occurs in an inference to best explanation. You look at a set of data points and say, what seems to be the most likely explanation of this? We can go ahead and throw out the alien thing I mentioned. That just seems too far-fetched. John was framed and then John did it. And then we start to ask, well, which of these two seems more likely? Well, why would John be framed? We don't really have any good reason. Then we conclude that John must have been the killer. So we work to the best explanation based on the data points that we have. Sally is a Democrat, therefore she is pro-choice. This is what we call an inductive generalization. This is also an argument about classes of things. It's saying, it's assuming in this argument that most Democrats are pro-choice. Notice that's a claim about the classes of things. Most people within this class, the Democratic Party, have this certain point of view. Sally belongs to this class, therefore she is likely to have it. But this, unlike the class containment argument I was talking about when we discussed deductive arguments a moment ago, in this example, we're just drawing a conclusion about the likelihood that Sally also holds these views. This final argument up here, this is what is called an argument by analogy. And in an argument by analogy, you compare two things in order to draw a conclusion. You may have heard this one. We actually reason with arguments by analogy all the time, but here's one I was told when I first started school, is that if you're a full-time college student, that's like having a full-time job. If you have a full-time job, you have to work 40 hours a week. So if you're a full-time student, you have to work 40 hours a week. And in that argument right there, I compared being a full-time student with having a full-time job in order to draw the conclusion that you should be studying 40 hours a week. And this is an argument by analogy because this argument comes in different various levels of strength. The conclusion is likely or unlikely depending on how strong the analogy is you're drawing. Being a full-time student is it very similar to having a full-time job? Are the two very different? If you think that the two are very similar, the conclusion is going to be more likely. If you think the two are very different, the conclusion is going to be less likely. Like the example I have up here on the overhead, the PowerPoint slide. Is federal spending similar to private individual spending? If you think the two are very similar, this conclusion is going to be, I don't know, fairly plausible. On the other hand, if you think, well, federal government, we're talking about an economy. We're not, and with individual, we're not talking about an economy. The two are very different. You're going to think this conclusion is not very plausible. So here's another example of an inductive argument. Now, it's going to be important that we're able to distinguish deductive and inductive arguments, and like with arguments in general, we are presented with indicator words that tip us off. And here's a small list of some deductive indicator words: certain, must, guarantees, necessarily, entails. Whenever you see a word like the conclusion must, or the conclusion is entailed, or the conclusion is necessary consequence of, you should start immediately thinking deductive argument. On the other hand, we have inductive indicator words. Words like probably, likely, plausible, reasonable. If someone says, well, this conclusion seems plausible, or this conclusion seems reasonable, you should go ahead and start thinking, inductive argument. Now, with indicator words here, as with indicator words in general, we don't always see them. You notice when we were distilling arguments, we had conclusion indicator words, we had premise indicator words, but they don't always appear. And it's the same thing here. These words don't always appear. But there's a bigger problem still, which these words are sometimes used incorrectly. And the way that most of the time they're used incorrectly is that you'll see people use deductive indicator words when in reality they're only trying to make an inductive argument. And the reason people do this is typically because they're trying to make the conclusion seem stronger than it actually is. They're trying to sell you on the conclusion, and so they use really strong language to seem confident. Whenever you're making an argument, there's the argument itself, and then there's your presentation of the argument. And I'm trying to think of an analogy here, but you think about going to a nice restaurant. I mean, you could have really good food, but if the restaurant is dingy and dirty and the plates are covered in filth, it's just going to detract from the overall presentation. So to have, just like with a good argument, you have the strength of the argument as it is by itself, but then also the presentation is going to factor into whether or not your audience is going to receive it. And so you'll find that people will sometimes use very strong language to really sell their point, to persuade the audience. And this is really, it's more a function of rhetoric or than actual logic. In logic, we don't really care about, I don't know, how convinced or confident the person is. But as a issue of rhetoric, it does come into play. So I want to give you an example and see what you think about this. But look at this right here. The sign on the vending machine says it is out of order. Therefore, it certainly is. And ask yourself, does this seem like a deductive argument or an inductive argument? Does it seem like a deductive argument or an inductive argument? And you might say, well, look, we have this indicator word, certainly. And you just told us a moment ago that certainly is a deductive indicator word. And it most certainly is a deductive indicator word. And so if you were to understand this as a deductive argument, then basically the argument is saying there's a sign on the vending machine which says it's out of order. Therefore, with 100% certainty, the machine must be out of order. And you start to think about that for a second. And you have to ask yourself, well, just because there's a sign on the machine, does that mean with 100% certainty that it's out of order? No, it doesn't mean that at all. I mean, maybe someone forgot to take the sign down. Maybe someone put it up there as a joke. Maybe someone thought the machine was broken and it really wasn't. There's a whole plethora of reasons why there could be a sign that says the machine is out of order when it actually isn't. And it's not just that there are possible reasons here that exist, it's that they're extremely obvious. I mean, I think anybody can see that just because there's a sign that says the machine is out of order, that's no guarantee that the machine would be out of order. And so what we have here is we have an opportunity to interpret what this person is arguing. On the one hand, they could be making a deductive argument. The problem here is if we understand it as a deductive argument, it is an obviously terrible deductive argument. It is just not going to work at all. The conclusion does not follow with any kind of certainty, and it's obvious that the conclusion doesn't follow with certainty. On the other hand, the person could be making an inductive argument and just using strong language to kind of sell the point. Or just using strong language, maybe it's not even their intention to sell the point. They're just misusing a term ever so slightly. And here we have to be charitable. This comes back to what I was saying a long time ago about interpretive charity. Do we interpret this argument as an obviously bad, terrible deductive argument, or a reasonable inductive argument with slightly strong language? Which seems like the more charitable thing to say? And in this case, I think it's the latter, that it's an inductive argument with overly strong language. It seems more charitable. So this is something we always have to be on the lookout for when we're trying to figure out, is it a deductive argument or is it an inductive argument? We have to pay attention to the language the person's using and ask what seems like a reasonable interpretation of what they're trying to say. You know, sometimes people make bad deductive arguments, and that happens, but you know, when it's a case like this where it's so obviously bad and there's an alternative and equally reasonable way to interpret it where it's not obviously bad, then we should opt for that instead. Now I want you to take a second here and look at these examples and see if you can figure out, is this argument deductive or inductive? I want you to just take a few minutes, pause the PowerPoint presentation, and walk through these and try to answer deductive or inductive. All right, well, let's look at these and see what you came up with. So John said Sally is coming, therefore Sally is coming. And this, I believe, it is obviously inductive. Just because John said Sally is coming, that's no guarantee whatsoever, and I don't think anybody would think that it was 100% guarantee that she would be coming. So this is an inductive argument. Anything that begins to exist has a cause of its existence. The universe began to exist, therefore the universe has a cause of its existence. And this argument is a deductive argument. And there are several ways we could have checked this, but I mean, you look at this argument right here and ask yourself, given that the premises are true, is there any way for the conclusion to fail to be true? And the answer to that is no. If the premises are true, the conclusion must be true. Now, some of you might be like, well, how do we know the universe began to exist? I mean, do we actually know that? Does not matter. Like I said before, what distinguishes deductive and inductive is not about the actual truth of the premises. Rather, it's about the relationship between the premises and the conclusion. Notice here also that in this argument, the concepts and the conclusion are completely contained within the premises. So right here we have two terms, the universe, and notice right here we have the universe. And then we has a cause of its existence, and then has a cause of its existence right here. Exact phrasing and the premises that we see in the conclusion. So this is a deductive argument. Henry is taller than John, and John is taller than Michael. The necessary conclusion is that Henry is taller than Michael. And this is a deductive argument also. And if you have any kind of doubt about it, you can just draw stick figures on a piece of paper, and you can draw one, Henry is slightly taller than John, and you can do John is slightly taller than Michael, and then you can see that the conclusion is that Henry is taller than Michael. And notice here we have an indicator term as well, the necessary conclusion. When you see something like that, the necessary conclusion, you should already get your brain geared up and thinking deductive argument. All right, finally, given present growth rates in underdeveloped countries, the limited practice of birth control, and the difficulty of slowing the current growth momentum, it can be said with virtual certainty that none of the people now reading this book will ever live in a world where the population is not growing. And this is an inductive argument. And we can figure this out from several different clues. One, we have this indicator phrase right here, with virtual certainty. Virtual certainty, of course, is not, actual certainty. It's near certainty. It's very likely, is what it's saying. So I don't want to say it never happens, but it's extremely rare where someone makes a deductive argument and uses inductive language. It just doesn't happen. I mean, the only reason I can understand why someone would make a deductive argument and use inductive language is if that person just lacks self-confidence for some reason. But this is clearly an inductive argument, and we have that indicator phrase right there with virtual certainty. Not only that, but we can look at the data that we're given and saying, given present growth rates in underdeveloped countries, and that's a key term within underdeveloped. It doesn't talk about developed countries, but present growth rates in underdeveloped countries, the limited practice of birth control, and the difficulty of slowing the growth momentum. All of those things could be true, and yet the population of the earth could stop growing because of things that happen in developed countries. So in this one, it doesn't seem like we have a deductive argument going on. Not only does the conclusion not follow with certainty, but the conclusion represents concepts that are not completely contained within the premises. The conclusion goes slightly beyond the information contained in the premises, and for that reason, it would also be an inductive argument. Well, I hope that the distinction between inductive arguments and deductive arguments is somewhat clear. What I want to do in the second half of this video lecture is talk a little bit about the different relationship that exists between inductive arguments and deductive arguments, and say a little bit about analyzing and evaluating each of the two arguments. Now, I'm going to speak more extensively about inductive arguments, but first I want to say a little bit about inductive arguments. And as I said several times, the difference between the two arguments is really a difference of how the premises relate to the conclusion. And when we talk about the relationship between the premises of an inductive argument and the conclusion of an inductive argument, we say that the premises support the conclusion. And we're using the term support here in a technical way. I know that sounds like just such an ordinary term, but in logic, we actually use it in a technical way. We say inductive support. An inductive argument, the premises support the conclusion. And we use that term precisely for inductive arguments. Now, as far as inductive support goes, it comes as a matter of degree. As I've said, in an inductive argument, the premises support the conclusion with likelihood or probability. Well, as I'm sure all of you are aware, probability comes in a range from 0 to 100. And so with that in mind, you could have, 20% support, 5% support, 90% support. Now, we're not going to get that precise, but we can say that the premises offer weak support. The premises offer moderate support. The premises offer strong support for the conclusion. And I'll give you some examples so you can see what I'm driving at here. But let's say Jones had the motive to kill Sally, therefore he killed Sally. Well, that's a really weak argument. The premise here doesn't offer very much support at all. In fact, I don't know how we could possibly quantify this, but maybe 1%? I don't know. I mean, it's just because someone had the motive doesn't really offer any kind of credibility to the fact that they were the killer whatsoever. I mean, hell, maybe we all had the motive. Maybe we all wanted the person dead. Maybe Sally was just a terrible human being. I don't know. But just having the motive is really, really weak evidence. I suppose you could say it is some evidence, but it's really weak. Now look at this argument. Jones had the motive to kill Sally, his DNA was on the murder weapon, and he had the opportunity. Now, that's not a necessary guarantee that he was the killer, but if you had the motive, your DNA is on the murder weapon, and you had the opportunity, you should contact a lawyer immediately because you're a person of interest. It's pretty strong support, and if you could prove in a courtroom that these three facts occurred, you would probably be seeking or looking at jail time in the near future. You see here, though, that we have weak evidence. We can have strong support. We can have evidence that occurs or support that occurs in between these. We can have stronger evidence still. Maybe let's say Jones had the motive. His DNA was on the weapon. He had the opportunity. And he was seen fleeing the scene of the crime. Well, that's stronger. Let's add to that he gave a confession. That's stronger still. So you see, we can keep getting stronger and stronger support. Now, I want to pause here and ask you a question. Suppose that all of this happened. That Jones had the motive, his DNA was on the murder weapon, he had the opportunity, he gave a confession, he was caught on videotape, and let's say 10 eyewitnesses saw him do it. And let's say his grandma said, yeah, I know he did it, I was there too. Whatever, I'm just adding to it here. At that point, would it be certain that Jones was the killer? And the answer to that is no. It would not be certain that he is the killer. And the reason I say that is because there would still be a possibility, no matter how thin of a possibility it is, that all of those things occurred and yet he wasn't the killer. So maybe he had the motive, but like we said, that doesn't really matter. Maybe his DNA was on the murder weapon because it was planted. Maybe he had the opportunity, but so did 100 other people. Maybe he gave a false confession. Maybe the person caught on camera was not Jones, but the video footage had been doctored. Maybe the 10 eyewitnesses, they saw, I don't know, a carbon copy of Jones, or maybe a person with a mask on. Maybe his grandma is out to get him because she stands to inherit a lot of money from him, or get a lot of money if he goes to jail. The point here, so she's lying. So the point here is all of these 7 facts I just listed, every single one of them could be true, and yet he not be the killer. Now, I know what I just said is far-fetched and absolutely ludicrous, but this is the point I want to illustrate here, is if all of that occurred, it would be 99.99999% chance that you were the killer. But as long as there's that 0.001 that you're not, there is not 100% certainty. And I say that to make this point that I'm about to make, which is that you never get to a point where an inductive argument becomes a deductive argument because there's just so much support and evidence. So I don't want you to get caught up in thinking that, if you get enough evidence, an inductive argument converts into a deductive argument. Never happens. Never happens. If something is an inductive argument, it's always an inductive argument. Whereas if something is a deductive argument, it's going to stay a deductive argument, and it doesn't just switch back to being an inductive argument because it's a bad argument. That's not the way it works at all. These are two different classes of arguments, and never shall the twains meet. So I say that because, number one, inductive does not become deductive arguments. And number two, when we're talking about deductive certainty, keep in mind that that is 100%. When we talk about deductive arguments, what that means when we say it's certain is that you can't even possibly conceive, imagine, no matter how far-fetched, imagine a way in which the premises are true and the conclusion is false. With something like an inductive argument, you can always imagine a way in which the premises are true and the conclusion is false. So I want to be very, very clear about this difference between them. Inductive are always inductive. They never become deductive. With inductive arguments, you never have 100% certainty. Never. It just never occurs. Some people find this a little unsettling because, we like we like certainty in life. The reality is we live in a world of probability. Most everything we do is based on probability, not certainty. And even though deductive arguments, they do have that nice stamp of approval of 100% certainty, deductive arguments tend to be a little less interesting, and they tend to advance knowledge less than inductive arguments. So, with everything, there's a cost and there's a benefit. With inductive arguments, you get the benefit of expanding your knowledge more so than you would with deductive arguments, but you have the cost of doing it at less certainty. So, deductive arguments, they offer certainty, but they tend not to expand knowledge and be quite as interesting. In any event, deductive arguments. All right, so when it comes to deductive arguments, as I've said, they are arguments that try to establish the conclusion with 100% certainty. The problem here is that's what the arguer is trying to do. In a deductive arguments, we're switching now to deductive arguments just in case you didn't get that. I've said everything I've got to say about inductive arguments for this class, but with deductive arguments, the person is trying to establish the conclusion with absolute certainty. The problem is this doesn't always occur. Someone is trying to establish the conclusion with certainty, but they mess up along the way. Think about if you've ever added numbers together. You know, you add 1 plus 1 plus 2 or something, and you try to establish the conclusion with certainty in this case, which would be 4, but you mess up. I don't know, you just write 5. Well, you made a mistake in your math problem, even though the conclusion was supposed to be established with certainty. Same thing happens with deductive arguments. And when a deductive argument does establish the conclusion with certainty, we say the argument is valid. When it fails to establish the conclusion with certainty, even though that's what it was trying to do, we say it's invalid. And I want to stop here and just pause for a second, because when you hear the word valid, you're likely to think the argument is good. And you hear the word invalid, you're likely to think the argument is bad. Get that out of your head immediately. We're using the terms valid and invalid in technical ways. Now, as it turns out, if an argument is invalid, then it is bad. But as you're going to see, just because a deductive argument is valid does not necessarily mean it's good. We're using the term valid and invalid only to refer to whether or not the conclusion is established by the premises with 100% certainty. Let me give you an example, and this will make a lot more sense. If I get an A, then I'll pass this course. I'm getting an A, therefore I'll pass the course. And I want you to think about this for a second. If 1 is true and 2 is true, is there any way that the conclusion could be false? And the answer to that is no. Now, some of you might be saying, well, what if you get an A but you failed on attendance? Well, if that's the case, then you're not getting an A. Then what you're basically saying, if you're like, well, you get an A but you fail on attendance, if that's the case, then 2 is actually false. But assume that 1 is true, assume that 2 is true, and then ask yourself, will 3 have to be true? Now, you might also be thinking, oh, well, what if you're getting an A at the beginning of the semester? Well, let's take it to mean, and this is going to be in parentheses at the end, I'm getting an A and the semester is over. All right, so just put that in parentheses at the end. So assume 1 is true, assume 2 is true, must the conclusion be true? And the answer is yes. The conclusion follows with 100% certainty given that the premises are true. We don't care if their premises are actually true, but just assume that they are. And the reason you might be saying, why are we assuming? Why do we care? Because what that's establishing, when you think about it in this hypothetical way, if the premises are true, then must the conclusion be true? You're basically establishing that there is the correct conceptual connection between premises and conclusion. Now look at a second example. If I get an A, then I'll pass this course. I'm passing the course, therefore I'm getting an A. Must the conclusion be true if the premises are? And the answer to that is no. And probably a lot of you are like, well, look, you could get a B, you could get a C, you could get a D. And when you're thinking like that, what you're doing is you're thinking of a way in which the premises could be true and yet the conclusion not be true. You're thinking of a way in which the premises could be true and the conclusion be false. So this is what basically an invalid argument is. I can't get my cursor. There we go. So if I get an A, then I'll pass the class. Well, that seems just like a trivial truism. I'm passing the class. Well, maybe you're getting a B. Well, then the conclusion doesn't follow. The conclusion is not guaranteed with certainty. And so this argument will be invalid. The conclusion is not connected with the premises in the right conceptual way. And this is the mark of an invalid argument. The premises, so think of it as like this: true, true, possibly false. So that's what basically an invalid argument is where the premises, assuming that the premises are true, it is possible for the conclusion to be false. And this, in fact, is how we're going to define the difference between validity and invalidity. Here are more formal definitions. So a deductive argument is valid just in case if the premises are true, then the conclusion must also be true. Whereas a deductive argument is invalid just in case it is possible, that's the key word there, for the premises to be true and the conclusion to be false. Like I was saying a second ago, the term valid only refers to the logical structure of the argument, not whether the argument is overall good or bad. If an argument is invalid, it's always bad. But I'm going to give you some examples in a second of arguments that are valid but are bad arguments. So validity is not a guarantee of goodness of the argument, but invalidity is a guarantee of badness of the argument. So when we're talking about, and I hope I'm not beating a dead horse here, but when we're talking about deductive validity, like I said, this is really a property of the relationship of the way the premises relate to the conclusion. It is a feature of how the premises relate. Do the premises guarantee the conclusion? Yes, it's valid. No, it's invalid. And in order to test invalidity, all you have to do is find any way possible, any way, doesn't matter how crazy or bonkers it is, but if you can find any way possible that the premises could be true and the conclusion to be false, then you prove that the argument is invalid. And this is what we call providing a counterexample. To provide a counterexample is just to imagine, it's hypothetical, imagine a way that the premises are true and the conclusion is false. And then if you can do that, you've demonstrated that the argument is invalid. So think about this argument right here. The streets are wet, therefore it is raining. Can you think of a way that the premise could be true and the conclusion be false? Think of that for a second. The streets are wet, it is raining. Can you imagine a way in which the premise is true and the conclusion is false? And you might come up with a lot of different things. Maybe it rained earlier. That's why the streets are wet now. Maybe an underground pipe exploded. Maybe there was snow and the snow melted. Maybe there was an overhead tanker filled with water and the plane exploded in midair and all the water went everywhere, right? I know that's pretty crazy, but the point here is coming up with a counterexample, it doesn't have to be a realistic possibility. And the reason that we're focused on just this hypothetical relationship of premise to conclusion is, like I said, we're looking at how the concepts in the premises are connected to the concepts in the conclusion. We're not addressing whether or not the premises are actually true. So the reality of the premises or the plausibility of the premises is not relevant at this moment. Rather, we're just like, wait, are these concepts connected correctly? Yes or no? Now, I want to make a couple of important points about deductive validity. And the first point I want to make about deductive validity is that a deductive argument, it's either valid or invalid. It's an all or nothing affair. I know that, in ordinary life, we'll say, well, that's a kind of valid point you make there. That's pretty valid, or that's not so valid. We'll use that kind of language of validity being a degreed property, but not right here. It doesn't make any sense to say a deductive argument is kind of valid. It's either valid or invalid. And the reason for that is either the premises guarantee the conclusion or they failed to guarantee the conclusion. It's one or the other. There's no in between. There's no halfway crook. It is just either deductive validity or deductive invalidity. Second, just because a deductive argument's premises are true does not entail that it is valid. Let me repeat that. Just because the premises are true does not entail that it's invalid. Here's the thing. You can have a deductive argument in which all the premises are true and the conclusion is true, and yet that doesn't make it a valid argument. You can have one in which the premises are true and the conclusion is true, and that doesn't make it a valid argument. I'm going to give you an example that's not quite like that, but I'm going to give you one in which the premises are all true, and yet the argument isn't valid. So look at this. All men are humans. Hillary Clinton is a human. Therefore, Hillary Clinton is a man. And this argument right here, number one, all men are humans. That's true. Hillary Clinton is a human. Questionable, but yeah, we'll go with it for the time being. True. Therefore, Hillary Clinton is a man. The conclusion does not follow. This argument is invalid. And some of you are like, yeah, that doesn't make logical sense. It's an invalid argument, despite having true premises. So don't get caught up in the actual truth value of the premises. All that matters is, if the premises are true, must the conclusion be true? Are the premises lining up with the conclusion in the right way? One final thing. There's a lot of words on the screen, but just listen to me. as I've said, the actual truth value of the premises doesn't matter. We're focused on the hypothetical. Notice I have that word if in bold and underlined. That's the key word here. Deductive validity is if the premises are true, then the conclusion must be true. You can have an argument that's completely valid, is 100% valid, and yet everything about it be false. The premises could be false, the conclusion be false, and yet the argument be 100% valid. And I'm going to give you an example of an argument that is valid despite having a false premise. If Moscow is the capital of the United States, then the U.S.'s capital is in Russia. Moscow is the capital of the United States, therefore the U.S.'s capital is in Russia. Now notice here premise 1 is true because we're assuming that Moscow is in Russia, and let's suppose that the Russians, conquered the United States and they ruled over us as a territory, but retained their capital in Russia. Just kind of how, think about like when Great Britain, had India under its control, or Great Britain had the U.S. colonies under their control. Well, the capital of the U.S. colonies was still in London, and so you can imagine, well, okay, if Russia was to conquer us, then our capital would actually be across the ocean in Russia, and our capital would be in Moscow. So 1 is true. Moscow is the capital of the United States. Well, hopefully you know your geography here, but no, that's just false. Washington, D.C. is. I have to highlight that because I saw one of these Jay Leno, Man on the Street segments a few years ago, and he went around asking people what the capital of the United States is, and half the people said New York City, and one girl, she actually said, does the U.S. have a capital? So always want to be clear, but it's Washington, D.C. So 2 is false. And yet, nevertheless, this is a valid argument, despite the fact that 2 is false. Why? Because if 1 is true, and if 2 is true, the conclusion must be true. Now, hopefully what I say next doesn't trip any of you up, but notice this argument has a certain kind of pattern. Look at this phrase right here, Moscow is the capital of the U.S. Notice that appears right here, and then in exact same terms appear right here. And then the U.S.'s capital is in Russia. Notice that appears, the U.S.'s capital is in Russia. And you can think of this argument in the following way, and I hope this doesn't confuse you, but imagine we took the letter A to equal Moscow as the capital of the U.S., and we took the letter B to equal the U.S.'s capital is in Russia. The pattern this argument follows is if A, then B. A, therefore B. And this is a valid argumentative pattern. Anything that follows this pattern will be a valid deductive argument. No matter what you substitute in place of A, as long as you do it consistently in the argument, no matter what you substitute in place of B, as long as you do it consistently in the argument will be valid, no matter what. And like I've been trying to say, you can have a terrible, stupid argument that's valid. This is a bad argument. It's bad because premise 2 is false. But you can have a bad one that is valid. So I'm going to come up with a ludicrous one here, but what if you said something like, if Britney Spears is the world's greatest dancer, then God exists. Britney Spears is the world's greatest dancer, therefore God exists. That is actually a valid argument. Some of you are like, what is this guy on? He's coming up with this stupid example, but that is actually a valid argument, despite it just being absolutely ridiculous. Why is it ridiculous? Well, because we all know Beyonce is the world's greatest dancer, not Britney Spears. No, because the first premise is utterly absurd. Britney Spears' dancing ability has nothing to do with the existence of God. But it's a valid argument because of the pattern it follows. It's a valid argument because if the premises are true, the conclusion must be true. There's no way for the conclusion to be false. Even conceptually, you couldn't come up with one in which you were assuming the premises are true and the conclusion is false. So you might be wondering, well, why do we care about validity or invalidity if you can have a valid argument that's bad? The reason, like I said, is because when we're evaluating a deductive argument, the first thing we have to do is check to make sure that the conclusion is lined up with the premises in the right way. I want to make another point here because I failed to make it earlier, but when we're evaluating arguments, we never ever describe inductive, going back to inductive arguments, we never describe those as being valid or invalid. That doesn't apply to them at all. The reason for that is because, technically speaking, every inductive argument is invalid. Every single inductive argument is invalid. You can always imagine a way in which the premises are true and the conclusion is false with inductive arguments. That's why I was saying we judge these two different classes of arguments by the rules that they're playing by. And it would not be fair to judge an inductive argument by deductive standards. Validity only is a property that we're going to ascribe, and only is a method of evaluation that we're going to use, or a term of appraisal we're going to use when we're talking about deductive arguments. We don't talk about inductive arguments as being valid or invalid. It's not a fair criticism to say it's invalid. So this is something we only apply to deductive arguments. And like I said, the reason we care about this is because we're trying to figure out, is the conclusion, does it fall out of the premises in the correct way? And you should think of validity as being one check on a checklist of things we have to sign off on before we can say if a deductive argument is actually a good one. There's a second thing that we're going to be looking at, though, if we're going to give a complete and total evaluation of a deductive argument. The first thing we have to know is it valid, yes or no? The second thing we're going to be interested in with deductive arguments is, are the premises true? So when we're evaluating a deductive argument, think of it as we have two things we have to check off or sign off on. Number one, is it valid? If we check yes, then the second question we come to is, are the premises true? And if a deductive argument is both valid and its premises are true, then we describe that argument as sound. And a sound deductive argument, that is basically a synonym for saying it is a good argument. On the other hand, if a deductive argument is either invalid or has false premises, then it is unsound. Now notice here that in order to be sound, two things have to happen: valid and true premises. Whereas to be unsound, one of two things can occur. Either it can be invalid or it can have false premises. Actually, a third thing, or both of those can exist. So the road to heaven is a straight and narrow path, valid and true premises. Whereas the road to damnation is broad and wide, invalid, false premises, or both. And I'm going to give you an example of a sound deductive argument. All fish have gills. Marlins are fish, therefore marlins have gills. And here, first question, is it valid? Yes, it is a valid argument. Are the premises true? Yes, the premises are true. Therefore, this is a sound deductive argument. And like I said, this is basically a way of saying it's a good deductive argument. I also said this earlier, but deductive arguments don't typically, not that interesting. This is one I don't know if any of you are terribly excited to read about, but this is an example of a sound deductive arguments. Well, let me just represent this very quickly visually. So we have a deductive argument. It can be either valid or invalid. If it's valid and has true premises, then it's sound. If it's invalid, I'm sorry, got a little ahead of myself. But if it's valid and has false premises, then it's unsound. And if it's invalid, it's always unsound. So, like I said, the road to soundness, the road to, heaven is straight and narrow. You have to follow one path, valid, true premises. Whereas the road to perdition, if you get off here, you have false premises, unsound. If you get off here, it's invalid, unsound. So, this is just a quick diagram to demonstrate everything I've been talking about to this point. Well, what I want you to do is take a quick moment and go through these and see if you can figure out if the arguments presented here are valid or invalid. So just take a second and think about these. All right, well, hopefully you were able to come up with some answers. Let's walk through these very quickly. If Bill asks Sharon out, then she'll go out with him. Bill didn't ask out Sharon, therefore she's not going to go out with him. And this is an example of an invalid argument. And this one's a little confusing, but think about this for a second. It could be the case that Sharon's like, yeah, if Bill were to ask me out, I'd go out with him. But then it could also be the case that Bill never does ask her out, right? He just never does. But maybe they get set up on a blind date and they don't know who they're going to go out with, and so they end up at dinner together. So that's one way that you could have both the premises be true and yet the conclusion be false. Here's another possibility. Maybe Sharon really likes Bill. She's like, if he would only ask me out, I'd go out. Or let me say it differently. If he would ask me out, I'd go out with him. And let's say he never does. And then she's like, I'm tired of waiting on his punk ass. So she takes the initiative and she asks him out. All right, that's another possibility as well. And if I haven't belabored this point enough, if I haven't emphasized it enough, when we're talking about invalid, think of it. You have a two premise argument with a conclusion: true, true, possibly false. Premise true, premise two is true, conclusion possibly false. And as long as you can imagine a scenario in which those three facts occur, where the premises are true and the conclusion is possibly false, invalid. If I had a dime for every time the Braves collapse in the postseason, I'd be a rich man. I don't have a dime every time they have collapsed, so I'm not rich. Well, maybe you won the lottery. Maybe you inherited money. Maybe you invested in Amazon. I don't know. But just because those premises are true doesn't mean that you're not rich. So this is also an invalid argument. If the battery on my watch were dead, my watch would stop. My watch stopped, therefore my battery is dead. This argument is also invalid. Why? Because, it's true that if the battery were dead, your watch would stop, but maybe you dropped your watch in water and it ruined it and the battery's still good. Or maybe sand got caught in one of the gears. Or maybe you dropped your watch and it shattered into a million pieces, but the battery's still good. Finally, everyone born before 1960 is at least 30. John is at least 30, therefore John was born before 1960. And this argument is also invalid. And this one's a little tricky, but let's look at the first premise. Everyone born before 1960 is at least 30. Well, as it turns out, that's actually true. So we don't even have to engage in this hypothetical if it's true. Because if you were born in 1960, well, I'm not good at math, but you'd be, what would that be? 59, maybe? I don't know. No, I don't know. You'd be well over 30. John is at least 30. Well, you just think about what year this is. What year would you have to have been born to be at least 30? Well, 30 years from today. If you were born 30 years from today, and that 30 years from today is well after 1960, right? It's well after 1960. So you could have been born in 1980, let's say, and you'd be at least 30 if you were born in 1980, but you would not have been born before 1960. So you had to pay attention to the language in this one in order to get it right, but it is an invalid argument because we can think of a way in which the premises are true and the conclusion is false. Well, hopefully you're getting a sense of all of this, because the good news is you're going to have some homework assignments. So here it is. You can also go on the course website and you can see it listed there. But just go through these exercises and identify if the argument is valid or invalid.